So in this question, we can see from the picture and the words that we have this block moving in this direction, this body moving in this direction. The two collide and stick together. And what we want to know is how much mechanical energy is lost during the collision. So what we are looking for is the change in kinetic energy. So delta EK is going to be the final kinetic energy minus the initial kinetic energy. Well, let's create an expression for each of those. So let's do our kinetic energy afterward. So we have 1/2 the mass. Now the mass is now 3m. We are not told what the velocity is, so that velocity is v prime squared. So we are left with 3/2 m v prime squared. We don't know what v prime is. Now, if we find the initial kinetic energy, well, that is going to be 1/2 this mass times this velocity squared, plus 1/2 this mass, which is 2m, times its velocity squared. So we have 1/2 plus 2/2 is 3/2 mv squared. That is our initial kinetic energy. So to find this initial, or the instantaneous velocity, we need to, since this is a collision, use momentum. So we have p0 equals p, and beforehand we have the momentum of this object, which is mv, plus the momentum of this object, which is minus 2mv. And that is going to be equal to the momentum afterward. The mass afterward is 3m, and that new velocity will be v prime. So looking at the left side, we end up with minus mv equals 3m v prime. Dividing both sides by 3m, we're left with v prime is minus v over 3. So now we have an expression for v prime. We can substitute that in over here, 3/2 times m times minus v over 3 quantity squared, which is 3/2 m v squared over 9. And that is 3/2 times 1 over 9 mv squared. So that gives us 1/6 mv squared. Now bringing that up to the top, we now know that we have a kinetic energy of 1/6 mv squared. Well, since we have, and we're subtracting these, we need the fractions to have the same denominator, then this, by that token, has 9/6 mv squared. I just multiplied this by 3 over 3. Multiplying it by 1 gives us 9/6 mv squared. So minus 9/6 mv squared, and we can see that is minus 8/6 mv squared, which reduces to minus 4/3 mv squared. So the change in kinetic energy is a loss of 4/3 mv squared, which is this choice. Now, if we'd done this logically before we did any calculations, since we know this is a sticky collision, we know there will be energy lost. So that takes this choice out for us. So our chances were 0.2. That was our probability of guessing correctly. By eliminating that 1, it takes our odds up to 0.25. Not all that helpful. And we can't just simply intuit what the other answers are and reasoning through. So eliminating 1 alone in this case isn't really helpful when there are 5 choices.